Hi everyone, welcome to our first lesson of geometry for the year, which is just defining points, lines, and planes. This is sort of the foundation for a lot of the work that we're going to do throughout the rest of the year. So a lot of this is just definitions, but then we'll look at some diagrams and label them. So let's start with points. Points are pretty obvious. They are a location in space. So a point is just a location. It doesn't have any size, it doesn't have any shape, it's just a location. So you've been using these on the coordinate plane. You know, the xy coordinate is a point. And when we're naming them, we'll always use a capital letter. So on the left here, that point is just called point A. And when we're using it in context, we won't even use the word point. We'll just refer to A, capital A, as the point. So points make up most of our work here. As you'll see below, a line is made up of 2 points. Actually, I should take off the number 2. A line is just made up of points. It's a bunch of points, an infinite number of points in a row. The 2 comes in on the next part. Any 2 points form a line. So if I over here draw 2 points, I can automatically connect them, using Notability, with a line. So any 2 points can be turned into a line. Let me erase that. A line has no thickness or width. It's not like a border where there's a thickness to something and you're defining it. It's infinitely thin because it's just a bunch of points in a row. Naming them is very important. Typically what we'll do, like for this line on the left over here, we'll call this line xy with this little line symbol above it. The arrows are important because lines go on forever in both directions. We could also call this line N. We could also call it line XY. But I would say this is probably the least useful. The reason why N is because there's a little lowercase n over here. That will not always be there for a lot of situations, and so typically we'll use 2 points. Collinear points are points that lie in the same line, like x and y over there. Non-collinear points are points that do not lie in the same line. And because every line can be connected with 2 points, there has to be at least 3 points for that to be relevant. So if we have point z over here, x, y, and z are non-collinear, which means x and y are in the same line, but z is not on that same line. So those are just 2 pieces of terminology you should know. Planes we won't really do as much with, but it's still important to know the basics of them. A plane is just a flat surface, and you've been using the xy plane for several years in algebra, so you're used to having the coordinate plane. And you can take any 3 points and make a plane out of them. So if you have 3 points in space, you can create a flat surface that contains all 3 points. And it goes forever in every direction. So with a line, we named it by 2 letters. A plane will name by any 3 non-collinear points. So any 3 points that are not all in the same line. So here we could call this either plane, JKL or KJL, it doesn't matter the order. But because there's this kind of script P in the bottom right corner, we more often will call that plane P. And again, we don't end up using planes a whole lot in our work, but it still goes along with this topic. Now, when you think about the interaction between lines and planes, we have to think about what happens when they intersect. If you have 2 lines that are not parallel, and they definitely intersect, they always intersect at a point. Unless it's the same line, in which case we know that's an infinitely many solutions problem back from algebra. But if we have 2 lines that reach each other, they always hit each other at one point. Similarly, if we have 2 planes, so imagine 2 pieces of paper and they cross each other. They cross each other at a line. And you can see that line here with this line K. Plane L is up and down and plane M is sideways. They kind of make a T shape. Where they overlap is a line. And you can even play with some paper to see how that is relevant if you can't picture that. So we won't do a lot of these together. We'll just do a couple of in each of the problems just so you get a sense for how they work. So for collinear points, you want to look for 4 points that fall on the same line. And I see 3 points there, I see 3 points there, so that's not useful. But I do see 4 points here. And you can name them in any order. We have H, N, K, and I. And remember that points are just letters, so we're putting commas in between them to list them. A line that contains point M. So we look for the line. Oops, I don't know what I just did. We look for the line here. I don't know why it keeps doing that. And there's a line. There's a few ways you can call that. You can call that line P, because it does have a name next to the line. But what we'll often do is do like MN, MO, or NO. The important thing here I want you to pay attention to is that we don't say MNO. For a line, you only use 2 letters all the time. And so that's a pretty good starting place there. Let's look at part number 2, something a little more interesting, part D, an example of 3 non-collinear points. So collinear means share the same line, and so don't share the same line. There's a lot of points in this plane M. We have A, D, E, and F all in here. We also have line J, and the plane again is called M. But B and C are not in that plane. B is up here, and C is down here. So there's a lot of different ways you can list these. But let me take B, because it's up above, and then take 2 of the letters in the plane. I'm just picking D and E because instead of using B, I could have used C here. But we're looking for 3 points that are not all on the same line. We could have also said ADE, ADF. There's a bunch of different ways you could do that. As long as they don't share the same line, you're good to go. Let's look down at C, because these can be kind of tricky. 3 coplanar points. I think we jumped over that before, but coplanar mean they share the same plane. So I'm looking at this bottom, kind of that plane R at the bottom. If I'm just naming 3 of them, let me do V, Y, and X. Which plane contains point X? Plane R. The intersection of plane R and plane ZVY. This is where, I don't like that they keep showing up there. ZVY is that one there. And let me make this a little bit thinner maybe so I can do this better. So ZVY is this plane. It kind of is at an angle, kind of standing up. Where does that hit plane R? And so if I look at that, plane R is on the bottom. That's going to hit there. Where does that overlap? It's going to overlap at a line. And the line is from V to Y. And here, planes are infinite, remember? It doesn't look like it is here because it's drawn to seem finite. But segment VY or line VY would be fine. How many planes appear in this figure? Well, we have this one. We have the one the one that we just did a second ago, this one here. We have, let me just write that down, VZY. We have the one sort of in front, this little pyramid we've got going on, VZW. We have the one sort of on the right side over here, this one over here. That would be ZWX. And again, the order doesn't really matter. There's the back of the pyramid, ZYX. And then there's that plane R at the bottom. So we have the 4 sides of the pyramid and then the base of everything. So that would be 5 planes in the figure. And then how many of the planes contain point W? Well, I could just actually look here for a second. That has W, that has W, and plane R also has W in it. So there are 3 planes that contain point W. That's probably a good example, or enough examples of these. Looking in 3 dimensions can be tricky at first if you're not used to it, so just take a look at the diagrams really carefully. Planes are confusing because they're infinite, but take a look at the diagram and do your best to determine where everything overlaps, and use highlighting, as I did, if necessary, to kind of help you visualize what you're seeing.